With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, our question is given as a proton, deuteron and alpha particle after being accelerated through the same potential difference. Okay, same potential difference enter a region of uniform magnetic field in a direction perpendicular to magnetic field. Find the ratio of their kinetic energies. If the radius of proton circular path is 7 cm, what will be the radii of path of deuteron and alpha particle? Here, 4 options regarding the ratio of their kinetic energies are given. Okay, so first of all, we can take which are the particles given here. We have given proton, deuteron and an alpha particle. Okay, so first of all we can write the charge ratio and mass ratio of the proton. If the proton is taken as a unit 1 or reference, the charge of proton is 1 and charge of deuteron is 1 and charge of alpha particle is 2. So 1 is to 2 is the ratio of the charge of these particles. What about the mass? If the mass of the reference particle proton is taken as 1, mass of the deuteron is 2 and the mass of alpha particle is 4. So the ratio of the mass of these three particles is 1 is to 2 is to 4. Okay, next we need to find the ratio of the kinetic energy. Since it is accelerated in same potential is same. Okay, so our equation for the kinetic energy is Q into V. Since it is same potential, the kinetic energy is proportional to charge. So kinetic energy of alpha particle and kinetic energy of deuteron and kinetic energy of proton changes same as that of the charge. So the ratio of the kinetic energy of these three particles, kinetic energy of proton is to kinetic energy of deuteron is to kinetic energy of alpha particle is given by same as that of charge 1 is to 2. So this is our answer for the ratio of the kinetic energy. So our option is 1 is to 2. So our option is B for the first question. Next we can find the radius of the path of the deuteron and alpha particle. Radius of the path of the proton is given as 7 cm. So radius of the proton is given as 7 cm. We know that when a charged particle is placed in a magnetic field, what happens? A force exerted on that particle which is given by Q into V cross B. Here it is in the question it is mentioned the magnetic field is given in a perpendicular direction. So QV cross B becomes QVB sine 90. That means force is equal to QV. And when a particle is placed in a magnetic field, when that particle is a charged one, it moves in a circular path. So the force exerted on that particle is given by centripetal force, which is given as mv square divided by r. So we can equate these two forces. So we get mv square divided by r equal to q into vb. We can cancel one velocity and we can write the equation for velocity v is equal to qbr divided by m. Okay, next we can find the equation for kinetic energy. We know that equation for kinetic energy is half mv square. Substituting the value for velocity, we get 1 by 2 m into v square is q square b square r square divided by m square, or kinetic energy is given by q square b square r square divided by 2m. Okay, then if we are considering the ratio, kinetic energy of proton is to kinetic energy of deuteron is to kinetic energy of alpha particle, here the quantity B, magnetic field, remains same. So only the quantity depends upon kinetic energy is proportional to q square r square divided by 2m. Now we can take the ratio of kinetic energy of proton and deuteron, then kinetic energy of proton and alpha particle. So first we are going to find the kinetic energy of a proton. divided by kinetic energy of a deuteron. What is our equation? It is proportional to q square r square divided by 2m. So charge of proton square into radius of proton square divided by 2 into mass of proton into kinetic energy of deuteron means charge of deuteron square radius of deuteron square divided by 2 into mass of deuteron. We can cancel 2. And what is the ratio of proton and deuteron charge? Charge of proton and deuteron is 1:1. So charge of a proton and deuteron is qp square and qd square is 1/1. Okay, what about the radius of the proton? It is given 7, so 7 square divided by radius of deuteron square into what is mass ratio of mass of deuteron and mass of proton. Here mass is given 1:2. So mass is given as 2 square divided by 1, which is equal to ratio of kinetic energy of a proton, and this ratio is given as 1. So 1 is equal to, we get 7 square into 2 square divided by RT square. Okay, no, there is no mass here, only 2. Mass of a deuteron is 2. Okay, so there is no 2 square. Therefore, it is equal, notice, therefore, RD, that is radius of deuteron square, is equal to 7 square into 2, or radius of deuteron is equal to 7 into root 2, which is equal to 9.89. So this is the equation for radius of a deuteron, which is in centimeter, 7 centimeters, so it is in centimeter. Next, we need to find the radius of the alpha. For that, we need to take the ratio of kinetic energy of a proton to kinetic energy of alpha. So what is the equation becomes? It is kinetic energy of proton square, radius of proton square divided by 2 into mass of proton, into kinetic charge of alpha square into radius of alpha square divided by 2 into mass of alpha. So here also we can take the ratio of a qp square by q alpha square into rp square divided by r alpha square into mass of alpha divided by mass of proton. What is the ratio of kinetic energy of proton and alpha particle? Proton and alpha particle is given by 1:2. Okay, so it is given by 1/2 equal to, and similarly 1/4, charge is 1/2, and the radius of proton is 7 square divided by radius of alpha is alpha square, mass of alpha is 4/1. Okay, so 4 get cancelled, and radius of alpha square is equal to 7 square into 2. Therefore, radius of alpha is equal to 7 into root 2, which is equal to 9.89 centimeter. So, this is a value of the radius of the path of the alpha particle. It is 9.89, and deuteron, it is 9.89. Okay.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.